Hi, and thank you for joining me again. Today we're going to talk about finding slopes and graphing lines. So let's just jump right into it. First, a little bit of vocabulary. The slope of a line is the rate of change. So notice it is a rate of change in the vertical direction, which is the up and down direction of a line, divided by the rate of change in the horizontal direction or left and right direction of a line. Okay, the symbol for slope that we use is m. So m is the change in the y direction divided by the change in the x direction. The little triangle symbol there is the symbol for the change in. It is called delta. So you could say this delta y over delta x, or the change in y divided by the change in x. Okay, and just a little reminder on slopes. We could have a positive slope. And remember, we always think about slope going left to right. So as we go from left to right, this one is going up, so that is a positive slope. This one going from left to right is going down, so that is a negative slope. A zero slope would be just a horizontal line, and then a vertical line going straight up and down would be an undefined slope. Okay, and just a quick review on the coordinate plane. The coordinate plane could also be called the XY plane or the Cartesian plane. It has several different names that we can use for it. Remember, the x-axis is the horizontal axis, the y-axis is the vertical axis. We have 4 quadrants in our coordinate plane, and it starts in the upper right corner here, quadrant 1, and it goes counterclockwise. So quadrant 2, quadrant 3, quadrant 4, and all of the points on the coordinate plane are in the form x comma y. So remember, we always go in the x direction first and then the y direction. So this is all of the coordinates in quadrant 1. Both the x and the y are going to be positive. When we go to the left into quadrant 2, we have negative x values. So it is negative x, but still positive y values. In quadrant 3, both the x and y values are negative, so negative x and negative y. And in the fourth quadrant, the x values are positive. Sorry, I made a mistake here. The x values are positive and the y values are negative. So it's x comma negative y. Okay, so here is our first example for the day. Find the slope of the line from the graph. So if we take a look, we have a line graphed here, and it's always nice to find a couple of easy points that we can locate on the line. So here I've identified both of the points on the axes. So here we have 0, -2, and here we have 4, 0. So to go from this point to this point, we're going up 2, and we're going to the right 4. So since both of those are positive and it is going up and to the right, so it is a positive slope. The change in y is 2 and the change in x is 4. So it is up 2 over 4, which we can reduce to 1/2. So our slope of this one is 1/2. In the next one, notice it is going down from left to right, so it's going to be a negative slope. And I didn't have points that were nice on the axes on this one, so I just located a couple of other points on the line. So I have this point here, and it looks like it is 1, 4, and over here this point is 3, -2. So if we start up here, and so to go from this point on down to here, we have to go negative. We're going down, so it's negative. So from 4 to -2, that's a -6 change. And from 1 to 3, that is a +2 change. So our change in y is -6, our change in x is 2. So we have -6 over 2, which reduces to -3. So we do have a slope of -3 on this one. Okay, next one. Find the slope of the line from the given points. So now, instead of having a graph like we had before, we're going to use 2 points to find our slope. So remember our slope formula. You might remember this from Algebra 1. the slope of a line is equal to y2 minus y1 over x2 minus x1. And you might remember this is being rise over run, or like we talked about, it's delta y over delta x, or the change in y divided by the change in x. Okay, so for our first example, we have the points negative 3, 2, and 1, negative 4. And we need to find the slope of those 2 points, or of the line between those 2 points. So remember we have y2 minus y1 over x2 minus x1. It doesn't matter which point we use as y2 and x2 or x1 and y1. So I'm just going to label them. x1, y1, x2, y2. Okay, so now it makes it really easy to take those values and put them into our formula. So y2 is negative 4, y1 is 2. So negative 4 minus 2 over x2, which is 1 minus, and x1 is negative 3. So we're going to minus a negative 3 here. Okay? Oops. I need to move it up a little bit. 1 minus negative 3. Okay. So negative 4 minus 2 is negative 6. 1 minus a negative 3 is a positive 4. So negative 6 over 4. And if we reduce that, we end up with negative 3 over 2 for our slope. Okay, next one. Have the formula written here, y2 minus y1 over x2 minus x1. I'm going to just make this x1, y1, x2, y2. Now again, we could order them in either order. I could have made this one x2, y2 if I had wanted. It doesn't really matter which one we use. Okay, so y2 minus y1 is 4 minus 2 over 1 minus 1. So 4 minus 2 is 2. 1 minus 1 is 0. Okay, so now we have 2 over 0. Well, that's not a good thing. That we can't divide by 0. So this particular slope is going to be an undefined slope. Okay, and in C, we have, once again, y2 minus y1 over x2 minus x1. I'm just going to switch it around this time and make this one x1, y1, and this one x2, y2. Again, it doesn't matter which order we go. So y2 minus y1 is 6 minus 6 over x2, which is 2 minus 4. And 6 minus 6 is 0. 2 minus 4 is negative 2. And 0 divided by anything is 0. So this one has a slope of 0. Okay, so just a quick note about graphing lines here. First, when you're graphing lines, please use graph paper. Quite often I see a lot of graphs that are just drawn on regular lined paper, and they end up not being very good graphs, and they're kind of sloppy. Can't really read them very well. So please, when you're making graphs, use graph paper. It's just so much easier on you. It's easier on me. So it's just easier all the way around. When you're using graph paper, of course, draw axes on the graph paper and use labels. So you want to be sure to label the x-axis, label the y-axis, and show a scale. So scale your graph. What I mean by that is show me how many units between each line on the graph paper. Usually you're going to use 1. Sometimes you might use something different. It just depends on the situation. Make your graphs kind of neat. When you're drawing a line graph and the line is very curved, it's kind of a confusing situation. So make sure when you're making graphs, make them somewhat neat. And if you're using more than one graph on a coordinate plane, write the equation beside each graph so that we know what graph goes with what problem. Okay, as a general rule, however, try to use different different coordinate grids with different graphs. It'll just keep everything neat, like I mentioned before, and just easier to look at. Okay, so we're going to graph some lines. First thing we're going to do is graph giving slope-intercept form. So slope-intercept form, you might remember from Algebra 1 again as y equals mx plus b. And of course, we already talked about m is the slope, and b is the y-intercept. Okay, so remember the y-intercept is where it crosses the y-axis. Okay, so here are some quick little steps for graphing using slope-intercept. First thing, plot the point of the y-intercept, and that's the point 0b. So if you remember on a graph, of course, if we have a coordinate grid here, our y-intercept is this point where it crosses the y-axis. And our x value right here is always 0. So it's always going to be this point 0 and then some y value. So in this case, our slope-intercept is always going to be 0, comma b, whatever this value is here at the end. Okay, so from there, you're going to use the slope to find another point on your line, and then connect the points with an extended line. And what I mean by an extended line is if you find another point on the line, don't just make it between those 2 points. Extend out your line. Show me that it's a line by making the arrows on the end, because remember that tells us that it continues on forever. Okay, so now we'll take a look at some examples of that. Okay, so graph the line y equals 3x minus 2. So I've kind of written the steps down here again just as a reminder for you. So the first thing we're going to do is plot the y-intercept. Well, since the x value is 0 on the y-axis, this is the point 0, negative 2. So, and again, here is the b value from our y equals mx plus b. It's negative 2. So we're going to plot the y-intercept, the point 0, negative 2. Okay. Use the slope to find another point. Remember, any number can be written as a fraction over 1. So even though this slope shows 3, remember we could think of this as 3 over 1, and that will help us to find our next point, because this is rise over run. So our rise is going to be 3, and our run will be 1. So let's go ahead and do that. 1, 2, 3, and over 1, our next point is going to be right there. Okay, now remember, we could go negative 3 in the y direction and negative 1 in the x direction. We could go down 3 and over 1 this way, and then use that point to connect our line. It just kind of goes off of my graph here, so I'm not going to do that. Okay, so now connect with an extended line. And since I'm doing it on the board here, it might look a little bit curved, but for the most part, that's a fairly accurate graph. So just connect it with an extended line, remember the arrows at the end, and we're done. Okay, next, graph the line y equals negative 3 halves x plus 1. So this one's kind of nice because now we have our rise and our run, and we have our y-intercept. So remember, I took away some of the help here this time. Plot the point, and we're going to plot the point 0, 1, because that is where the y-intercept is. So 0, 1 is right there. Use the slope, negative 3 over 2. Now, in this particular case, we can go negative 3 in the y direction and positive 2 in the x direction, or we could go positive 3 in the y direction and negative 2 in the x direction. If we go positive 3 in the y direction, it does kind of take us off the graph, so I'm not going to use that one. I'm going to go down 3, 1, 2, 3, and over 2, and plot our point. So our change in y is negative 3, our change in x is positive 2, and now draw the line. So I will do my best here. Okay, so there is our line for that one. Okay, so that was slope-intercept form. Now we're going to take a look at standard form. Standard form is a different form of a line. It is written as ax plus by equals c. So we have two different methods that we can use for graphing a line in standard form. The first one is simply to change our equation, just manipulate it algebraically so that it's in standard form. The other, or I'm sorry, so that it's in slope-intercept form. And then the other method is to graph using intercepts. So we'll take a look at one that we change into slope-intercept form, and then the next example will be graphing using intercepts. Okay, so first, graph 3x plus 4y equals 12 by first changing into slope-intercept form. So we need to take this equation and manipulate it algebraically so that it's in slope-intercept form. So first thing we want to do, we want to get y by itself, of course, because it's y equals mx plus b. So we want to get y by itself. So let's move the 3x on over. So subtract 3x, which gives us 4y equals negative 3x plus 12. And now in order to get y by itself, remember since this is 4 times y, we're going to do the opposite and divide. So divide everything by 4. There is a temptation for some students just to divide the first thing they see by 4, or sometimes the last thing by 4, but we have to divide everything by 4. Okay, and when we do that, the 4's cancel here, leaving us just y equals negative 3/4 x, and 12 divided by 4 is 3. Okay, so now it's in slope-intercept form. Let's just graph the line. So we have plus 3. We're going to go down 3 and over 4, down 3 over 4, and now I'm going to just connect with a line, and there we go. So we're all done. Okay, so next what we're going to do is graph by finding intercepts. So graph 2x minus 6y equals 12 by finding intercepts. So for our answer, remember the y-intercept is the point 0, b. So we can find that intercept by putting in 0 for the x value because, well, that's what the x value is at the y-intercept. And when we do that, we can solve for y. So notice I took the equation down here, 2x minus 6y equals 12, but I put 0 in for x. So 2 times 0, of course, is 0. So we end up with negative 6y equals 12. And then divide both sides by 6, we get y equals 2. So our y-intercept is 0, negative 2. We can do the same exact thing to find the x-intercept, only this time we're just going to put 0 in for y. So the x-intercept is where y equals 0, or x comma 0. So put 0 in for y and solve for x. So 2x minus 6 times 0 equals 12. 6 times 0 is 0, so we have 2x equals 12, so x equals 6. So our x-intercept then is 6, 0. So we have 2 points on our graph, 0, negative 2, which I will put right here, and we have the point 6, 0, which is right here. And now since we have 2 points on our graph, we can just connect them with a line. Oops. Okay, connect those 2 points with a line and draw your graph, and you're done. Okay, just a few more quick notes here. First of all, graphing horizontal lines. So for example, graph the line y equals 3. So if you look at that, notice that we could rewrite this or think of this as y equals 0x plus 3. So our slope in this case is 0, and our y-intercept is 3. So thinking about slope-intercept form when graphing these is kind of helpful to help us graph the line. So slope of 0, y-intercept of 3. So I just made my line up here. It has a y-intercept of 3 with a slope of 0. So another way you can think about this is no matter what the value of x is, y is always positive 3. Okay, so we can kind of think the same way with vertical lines, except in this case, graph x equals 2, we'll notice there is no y-intercept because there's no y in the equation. So we don't have a y-intercept. So this line must be parallel to the y-axis. And you can think just kind of similar to over here, no matter what the value of y is, x is always -2. And so we can plot our line here with a vertical line going through -2 in the x direction. Okay, well, I hope that was helpful for you. Thank you very much for joining me today, and I'll see you again soon.